All right, let's talk about the service mesh. Not just getting it installed, but what comes after. The stuff that really matters when you're running in production. Today, we're digging into mastering day two operations, specifically for Istio on Azure Kubernetes Service, or AKS. So, you did it. You got through all the YAML, you deployed Istio, your services are all nicely meshed, and everything's lighting up green. Feels pretty good, right? You might think you've climbed the mountain and the hard part's done, but here's the reality check. In a lot of ways, the real work is just about to begin. Day one is the sprint. Day two is the marathon. And to really get into this, I want to start with a story. Because let's be honest, nothing teaches a lesson quite like a real-world, everything's-on-fire production incident. This is the story of a routine upgrade that went completely off the rails, and it's the reason for the entire playbook we're about to walk through. So picture this. It all started as just another Tuesday maintenance window. An hour before things went bad, the team kicked off what they thought was a super simple Istio version bump. But just 5 minutes in, bang. The pagers start screaming. PagerDuty is lighting up everyone's phones. 20 minutes in, it gets worse. Services all over the place start throwing 5xx server errors. The team is scrambling, and by the 30-minute mark, there's no other choice. They have to hit the big red button and initiate a full rollback. A total day two nightmare. So what on earth happened? Well, the postmortem was really interesting. The root cause wasn't some huge, obvious mistake. It was something tiny, almost invisible, a subtle breaking change deep inside the configuration APIs of the new Istio version. It was the kind of thing none of their existing checks and balances were ever designed to catch. That incident was painful, for sure, but it led to this really powerful, simple resolution. Never again. This became the team's rallying cry. It was the moment they decided to completely tear down their old approach and build a proactive, super robust way of operating their service mesh. And the very first thing they changed, and you could argue it's the most important, was building their new playbook on a foundation of automation. They turned to GitOps as the way to enforce consistency and, frankly, to get human error out of the equation. Now, if you're not super familiar with GitOps, don't worry. The core idea is actually pretty simple. It's an operational framework that basically takes all the best practices we use for our application code, things like version control, pull requests, and CI/CD, and applies them to our infrastructure. The key concept is that a Git repository becomes the one and only source of truth. What's in Git is what's in your cluster, period. And this new workflow they built is just chef's kiss. Any change, doesn't matter if it's a tiny traffic rule or a major Istio setting, it has to start as a pull request. That PR then gets hammered by automated validation tools, checking it against all their policies. Only after it passes all the checks and gets a thumbs up from another human is it merged. And from there, a GitOps agent inside the cluster just picks it up and makes it so. The big takeaway? No more manual kube control apply. Everything is audited, validated, and completely automated. But look, automation is only one side of the coin. It locks down how you make changes. The other side is making sure that what you're deploying is actually safe. And that brings us to the second pillar of their new playbook, a serious, almost obsessive focus on validation. This became their new mantra. It sounds so simple, right? But it is incredibly powerful. You just cannot afford to wait for production traffic to tell you that a service mesh upgrade has a breaking change. You have to, absolutely have to, validate every single thing in a high-fidelity, non-production environment first. And to make that validation actually mean something, they had to think beyond just testing their own applications. They started defining and measuring service-level objectives, SLOs, for the service mesh itself. We're not talking about your app's latency here. We're talking about the health, the performance of the Istio control plane. Is the mesh itself healthy? They set real, concrete targets they could measure. For instance, is the Istio control plane successfully pushing its configuration out to all the little sidecar proxies at least 99.9% of the time? And is the latency for those pushes staying under 50 milliseconds? By watching these specific SLOs in their staging environment during an upgrade, they could finally spot those subtle breaking changes long before they ever had a chance to touch a real user. Game changer. So, we've got the technology covered with GitOps, and we've got the process locked down with pre-deployment validation, but there's a third, super critical piece of this puzzle, and it might be the trickiest: the people. You have to solve the organizational problem of who owns what. This is the question that just paralyzes teams during an outage, right? Is it the platform team's problem because, hey, Istio is infrastructure?
Or is it the app team's problem because their service is the one that's failing? If you don't have clear lines of responsibility, all you get is finger pointing and chaos when you can least afford it. To fix this, they drew a very clear line in the sand. In their new model, the central platform team owns the Istio lifecycle. That means installs, upgrades, and the overall health of the control plane. They set the ground rules. The application teams, on the other hand, own their specific configurations inside the mesh, things like their virtual services and gateways, and they are responsible for their own services SLOs. This simple split created really clear boundaries, and it empowered both teams to do their jobs. Okay, we've covered a lot of ground. The war story, the tech, the process, the people. Let's boil this all down into an actionable checklist you can take with you to start mastering your own day 2 operations. Here it is, your foundation for a stable, reliable service mesh. First, keep your Istio versions current. Seriously, don't fall more than 2 versions behind. Second, standardize 100% of your mesh config through GitOps. No exceptions. Third, validate every single change in a non-prod environment that actually looks like production. Fourth, define and monitor SLOs for your mesh control plane. Treat it like a critical service. And finally, clearly write down and communicate who owns what between your platform and app teams. And I want to leave you with this one last thought. A service mesh isn't something you just install and forget about. It's not a project with a start and end date. It is a critical piece of living infrastructure that all your applications depend on. It's a product, and it requires the same care, the same maintenance, and the same operational rigor as any other product you deliver to your customers. So the real question is, are you treating it that way?